Functional Physio presents ePoster 2020. Associated by Mind Academy and Sportson.
Presenter Aatiruddin Khan. Untitled Brachial Plexus.
Hello everyone who is watching out there. Myself Aatir, and I am going to present before you the poster on brachial plexus, and this poster will cover the structure, function and the relevant applied anatomy of it. So let's start with the structure of the brachial plexus. It is a network or plexus of nerves formed by the anterior rami of the cervical nerves and the thoracic nerve. The cervical nerves include the C5, C6, C7 and C8, and the thoracic nerve is a single T1. This plexus extends from the spinal cord to the armpit. The plexus is divided into roots, trunks, divisions, cords and branches. There are 5 roots, 3 trunks, 6 divisions, 3 anterior and 3 posterior, 3 cords and 5 terminal branches, and other than terminal branches there are pre-terminal branches or collateral branches. There are 5 terminal branches: axillary nerve, muscular cutaneous nerve, median nerve, radial nerve and ulnar nerve, and the rest are the pre-terminal branches such as suprascapular nerve, nerve to subclavius, etc. Now coming to the roots, as you can see in the diagram, the black colored portion, these are constituted by the anterior primary rami of spiral nerves C5 to C8 and T1, with smaller contributions from the anterior primary rami of C4 and T2. These are the roots. The origin of the plexus may shift by one segment either upward or downward, resulting in a prefixed or postfixed plexus, which can involve C4 and T2 respectively. These roots merge to form the trunks. As you can see in the orange colored portion, there are 3 trunks: the upper trunk, middle trunk and the lower trunk. The upper trunk is formed by the joining of the C5 and C6, and the root C7 forms a middle trunk, and roots C8 and T1 join to form the lower trunk. Now see the trunk region, which is green. Each trunk divides into ventral and dorsal divisions. There are 3 trunks, so the total divisions become 6, and they supply the anterior and posterior aspect of the limb. These divisions join to form 3 cords: the lateral cord, the medial cord and the posterior cord. The lateral cord is formed by the union of ventral divisions of the upper and middle trunks, that is only 2 divisions. The medial cord is formed by the ventral division of the lower trunk, that is 1 division. And the last posterior cord is formed by the union of the dorsal divisions of all the 3 trunks, that is it is formed by the 3 divisions. Okay, so now I want to make you clear about all the branches of this plexus and their functions. There are branches of roots, trunks as well as of the cords. In roots, first there is a branch to the phrenic nerve, which can be seen in this plexus. It has a root value of mainly C4 and a little part from C5. It supplies the thoracoabdominal diaphragm. Second, there is a branch to dorsal scapular nerve. It has a root value of C5 and it supplies the rhomboid minor and rhomboid major muscles. Third, there is a long thoracic nerve which has a root value of C5 to C7 and it supplies the serratus anterior muscle. And there are also the branches to longus colli and scalene muscles, root value of C5 to C8, which is known as the muscular branches, as shown in the figure. In the trunk region, there are only 2 branches, and which you can see are arising from the upper trunk only. These are the suprascapular nerve and the nerve to subclavius. Suprascapular nerve has a root value C5 and C6. This nerve supplies the supraspinatus and infraspinatus muscles, and the nerve to subclavius has a root value of C5 and C6 and it supplies the subclavius muscle. In the cords, there are 3 branches of lateral cord and 5 branches for both medial and posterior cord. The first branch of the lateral cord is the lateral pectoral nerve with root value of C5 to C7. It supplies both pectoralis major and pectoralis minor muscles. Second is the muscular cutaneous nerve with root value of C5 to C7. It supplies the coracobrachialis, biceps brachii and the brachialis muscles. Third is the lateral root of median nerve with root value of C5 to C7. Along with its medial root, it forms the median nerve, which is the chief nerve of the muscles of the front of the forearm. The first branch of the medial cord is the medial pectoral nerve with root value of C8 and T1. It supplies both the pectoralis minor and pectoralis major muscles. Second branch is the medial cutaneous nerve of arm with root value of C8 and T1. It carries sensory impulses from a small area of medial side of arm. Third is a medial cutaneous nerve of forearm with root value of C8 and T1. It carries sensory impulses from large area of medial side of the forearm. Fourth is the ulnar nerve with root value of C7, C8 and T1. It is a nerve of 1.5 muscles of front of forearm and 15 intrinsic muscles of the palm. Fifth is the medial root of median nerve with root value C8 and T1, and it joins the lateral root to form the median nerve. Now the branches of the posterior cord. First branch is the upper subscapular nerve with root value of C5 and C6. It supplies the subscapularis muscle. Second is the nerve to latissimus dorsi with root value of C6 to C8, and it supplies the muscle latissimus dorsi. Third is the lower subscapular nerve with root value of C5 and C6. It helps the upper subscapular nerve in supplying of the subscapularis muscle. Fourth is the axillary nerve with root value of C5 and C6, and it supplies the deltoid muscle. Fifth is the radial nerve with root value of C5 to C8 and T1. It supplies all the three heads of the triceps brachii muscle, and it supplies 12 muscles on the back of the forearm. Coming to the left portion of the poster, which is a portion of the applied anatomy, brachial plexus can be injured, and these injuries are categorized according to how badly the nerves are damaged. I have shown here the attachment of the nerves to the spinal cord. As you will see, the first one is the normal root which is attached to the spinal cord normally. Then one type of injury that can occur is the avulsion. In this, the root of the nerve is completely separated from the spinal cord. It is considered as the most severe type of injuries of the brachial plexus. The second type of injury is the neuropraxia. In this, the nerves are stretched from the spinal cord, and it is considered as the less severe type, as there will no such major damage. The third one can be the rupture. Here the part of the nerve is actually torn, and also there can be neuroma, in which scar tissue forms on the stretched nerve as it repairs itself. And lastly, it is also important for us to know about the rare type of injury which is known as brachial plexitis. This is a rare syndrome for which no cause can be identified. It is also called Personage-Turner syndrome. Now coming to the bottom left portion of the poster, here we will talk about the specific type of deformities that can occur due to the above mentioned types of injuries. So let's talk about Erb's paralysis, which is quite famous and most of you might knew about it. Look at the picture of the hand drawn here. The nerve roots involved here are mainly C5 and partly C6. It is caused by the undue separation of the head from the shoulder, which can commonly encountered in some situations like birth injury, fall on the shoulder, or during anesthesia. The muscles paralyzed here are mainly biceps brachii, deltoid, brachialis, and brachioradialis. Partly supraspinatus, infraspinatus, and supinator can also be damaged. In this deformity, the arm hangs by the side, it is adducted and medially rotated. The forearm is extended and pronated. And this deformity is also known as policeman's tip hand, or waiter's tip hand, or porter's tip hand. The movement that are lost here are abduction and lateral rotation of the arm at shoulder joint, flexion and supination of the forearm, biceps and supinator jerks, and sensations are lost over a small area over the lower part of the deltoid. Second one is the Klumpke's paralysis. It involves the lower trunk of the brachial plexus. The nerve roots involved here are mainly T1 and partly C8. The injury is caused by the undue abduction of the arm, as in clutching something with the hands after a fall from a height, or sometimes in birth injury. Muscles paralyzed here are intrinsic muscles of the hand and the ulnar flexus of the wrist and fingers. In this deformity, we can see claw hand due to the unopposed action of the long flexors and extensors of the fingers. In a claw hand, there is hyperextension at the metacarpophalangeal joints and flexion at the interphalangeal joints. This deformity includes the following points. First, biceps and supinator jerks are lost. Second, there is complete claw hand. Third, cutaneous anesthesia and analgesia in a narrow zone along the ulnar border of the forearm and head can be seen. Fourth, there is vasomotor changes. In this, the skin area with sensory loss is warmer due to arteriolar dilation. It is also drier due to the absence of sweating as there is loss of sympathetic activity. Fifth, there are also trophic changes. Long standing case of paralysis leads to dry and scaly skin. The nails crack easily with atrophy of the pulp of fingers. And the last is the Horner's syndrome. There is ptosis, meiosis, anhidrosis, anophthalmos, and loss of ciliospinal reflex. This is because of injury to sympathetic fibers to the head and neck that leave the spinal cord through nerve T1. Injury to the nerve to serratus anterior cause winging of the scapula. This nerve is also known as the nerve of Bell. The injury is caused due to sudden pressure on the shoulder from upside or carrying heavy loads on the shoulder. The deformity includes winging of the scapula, that is excessive prominence of the medial border of the scapula, as you can see in the figure. Normally, the pull of the muscle keeps the medial border against the thoracic wall. Here, the following actions are affected. First, there is loss of pushing and punching actions. During attempts at pushing, there occurs winging of the scapula. Second, arm cannot be raised beyond 90 degrees, that is overhead. Abduction is not possible as it is performed by the serratus anterior muscle. So this ends the applied anatomy, and that's all about the brachial plexus. Thank you so much.